Yes. In the last class, we have talking about multiple items support, right? And how to find the support of that. So let us see, there are two steps in a Apriori algorithm. What is that? Joining step and pruning step. So let us see the example. These are the frequent items at level 3. Okay. So the joining step will produce these items 1, 2, 3, 5. Okay, 1, 3, 4, 5 and 1, 4, 5, 6. Now try to understand the pruning step. The pruning step will, we have 3 items. Now we are deleting 1, 4, 5, 6 because 1, 5, 6 is not there in the frequent items. It's F3. Now we have 1, 2, 3, 5 and 1, 3, 4, 5. But though 3, 4, 5 is not there in F3, we are not going to delete 1, 3, 4, 5 from the set. Why? Because if you see this algorithm, okay, if the first element is there in S and MIS of candidate of C2 is equal to MIS of C1, then only you can delete the item. Okay, for example, if you see, take the example, we are removing 1, 4, 5, 6. Okay, 1 minute. Okay, the first element, that is 1, 4, 5, C1, C of 1 is equal to this one. If you see, C of 1 belongs to S and MAS of C2 is equal to MAS of C of 1. If this is, if the first element belongs to the candidate, then you can delete it. But in the 1, 3, 4, 5, 1 does not belongs to 3, 4, 5. So you cannot delete this. Remember the rule. If the first element belongs to the subset, then you can delete. If the first element does not belongs to the subset, okay, then you cannot delete it. Is this point clear? Pruning step. So joining step you have understood. It's very simple. Okay. Pruning step. Okay. Take these 3 items. We are removing 1, 4, 5, 6 because 1, 5, 6 is not there in F3. This is clear. Yes, is that point clear? Okay, right. There is another rule when pruning MS algorithm, MS in MS Apriori algorithm, there is another rule that if the first element of the candidates is equal to the first element of the frequent items, then you can delete it. Otherwise, you cannot delete. See, in this case, 1, 4, 5, 6, 1, 5, 6 is not there in F3. One condition is met. And the second condition is the first element, candidate of 1, C of 1 is 1. And the subsequent 1 in the subset also 1. The first element belongs to this subset, then also you can delete. But in this case, the first element does not belongs to 3, 4, 5. Then you cannot delete. This is the second rule. ఒకసారి మళ్ళీ చూసుకోండి ఎగ్జాంపుల్. షల్ ఐ ప్రొసీడ్? చూడండి ఇక్కడ ఫస్ట్ ఎలిమెంట్ 1 is there in 156, but 1 is not there in 345. Though 345 does not belongs to F3, but the first C of 1 does not C of 1 which belongs to S does not belongs to the subset. You cannot delete it. Okay, why this rule is there? Because see, 345 may not be frequent, but 1345 may be frequent, because one may have the minimum item support. Okay, that's why this is the rule. If MAS of 3 is, if MAS of 3 is equal to MAS of 1, then in that case also you can delete the set. Okay, is this pruning step clear? Okay. So rule generation. Previously, for finding the validity of the items, we have what is the rule we are seeing? We have seen in MS Apriori to find the validity of the rule. The actual support should be greater than minimum of all minimum items in the rule. Yes or no? What is the rule? Validity rule. The actual support should be greater than the minimum of all MS values of items that are there in the rule. So sometimes you are checking the validity of the rules and accordingly you are generating the rules. All valid rules may not be important to you. Okay, again you want to filter, so there should be some threshold. So in that case you may go to confidence. Additionally, apart from what the main difference between general a priori and MS Apriori, you are checking the validity of the rule using the formula, that is support should be greater than minimum of all MS values of the items which are there in the rule. Secondly, again, if you want to go with the confidence, so mostly we won't use this one, but if at all you want to go with confidence also, then if you see this example, this is common or dot. Clothes and bread may not be frequent, but shoes, clothes, bread may be frequent. If this is frequent, you have to generate the rule from shoes, clothes, bread. Okay, if I want to generate shoes, clothes, bread with some confidence, I need the support. But as clothes and bread is not frequent, in frequent item sets, I am not going to calculate the support of shoes, clothes, bread. If I am not calculating the support of this shoes, clothes, bread, then how can I calculate the confidence of this shoes, clothes, bread rule? Have you understood the question? When you are calculating the confidence, okay, you require the support in the first scan in the frequent item sets only. You are calculating the support. Again, for calculation of the confidence separately, you are not going to calculate the support, right? Because already you have calculated. But in this case, you see the example, clothes and bread is not frequent, so our algorithm does not calculate shoes, clothes, bread support as clothes, bread is not frequent. But since this is an MS Apriori, shoes, clothes, bread may be frequent. Then how, without the support of shoes, clothes, bread, how you will calculate the confidence? This is the question. Okay, I am not asking the answer. Have you understood the question? Yes. So the above problem mainly occurs only when the item that has the lowest MS value in the item set is in the consequent of the rule. Okay, shoes is having the lowest MS value. So this problem ante close bread may not be frequent, but shoes close bread or some may be frequent. And the rule close bread shoes cannot be calculated. Okay, because you don't have the support for closed bread. So the main thing, this type of problem occurs only when you have the lowest MS values in the consequent of the rule. So in that case, a special line is given that if candidate minus the first item C of 1, okay, which has, because we are assigning the values according to the lowest MAS, is contained in the transaction, then even that count should also be included. This additional line should be included in the algorithm. Okay. So MS Apriori is a very slow process. That is, it's a time consuming process and it takes more memory. This is the main drawback. Right. As we are including multiple item supports and we are finding the frequent item sets for both the frequent items and the rare items, it is more realistic when compared to your general a priori algorithm or general single support rule. Okay, so this items will include rare items as well as frequent items. And the note is, if you set MS values of any item is equal to 100%, that means that we don't want to include that item, not to generate rules which includes that item, because it is having 100% MS value. So we have seen how to calculate the frequent item sets. So let's have a simple summary. You need to find all the rules of of X associates Y's, which satisfies the given support and confidence. Okay. So for that, we are specifying multiple item support. That means for each item, we are giving a support value. If your item contains only single items, only one, then simple support count should be greater than or equal to MS value. If your condition, say in X associates Y, X is called as condition and Y is called, which I have repeated many times, Y is called, in the rule X associate Y, X is a condition and Y is a consequent. Very good. So if X is greater than or equal to 1, then you are applying this value, this rule. It is the actual support count should be greater than or equal to minimum of all the items that are present in the rule. And to avoid F2 problem, what is F2 problem? The combination of frequent items and rare items. we are introducing a constraint called as support different constraint. That is, the maximum support of all the items should be less than or equal to 5 value. And the 5 value is given by the user. Okay. And in the last class, I think I have asked how we are taking the minimum item support. Okay. I said that it can be less than 10%. But here, this is also applied. We are calculating the support of each item.
Okay,
and I think I had last time asked the question.
No, ma'am. I don't think I asked, ma'am.
Someone asked how we are calculating the MS value. And I could remember.
I think that was Harshit, ma'am.
Arshada, okay. So multiplied by sigma, where sigma belongs to 0 to 1. This the value you can decide according to your problem, whether you are going with no one will go with 0, okay, 0.1 or something within in the interval of 0 to 1. Okay, right. Class association rules. Can you guess what will be a class association rule? Any guesses? What a rule contains? A rule contains condition and a consequent. So if I say X associate Y, what it means? Whenever X is there, Y will also occur, the occurrence of Y. But vice versa is not true. But in class association rule, the target is fixed. That is, the consequent will be fixed. Let us see. In normal association rules, there will not be any target. If you take the item set, any items from the item set can be there in conditional set and it can be in consequent. But there are some topics wherein the targets are fixed. For example, if I want to find all the synonymical words for data mining, okay, so my target data mining is fixed, and I want to say what are the words that are associated with the data mining. So the conditions will differ, but the target is fixed. Okay, you need to mind such rules where the target is fixed. Clear? Class association rules. See, mostly exam law, you will not ask us explain about class association rules. Simply will ask explain about car. Okay, remember class association. Similarly, what is MAS? Explain about MAS. Explain MAS algorithm. Full forms may not be given. Problem definition. So let T be a transaction data set which consists of all n transactions, and each transaction here, the data set contains a label y, and the set of all, this is small y, the set of all class labels small y is represented as capital Y, and I intersection y is a null set. So X associates Y, all the items will be taken from I. All the items of the X will be taken from I only, and in the consequent sides, all the consequents are taken from the set Y only. You cannot interchange. For Y, you cannot take from I, and for X, you cannot take from Y. Okay, you need to remember. Is this point clear? Again, I am explaining. You have item sets and you have class labels. Class labels will be there in conditional set. that is in X, and consequent values will be taken from class labels. And the definition of support and confidence is similar to your ordinary support and confidence of normal association rule. So this is the set, document set. Okay, document 1 consists of student, teach and school. Student, teach, schools, all these are items. And the class label here is education and sports. So let the minimum support be 20%. Minimum confidence is 60%. And we are generating these two rules. Whenever student school is there, education, its support is 2/7. Student and school ekkadundadi? Student school education, student school education. 2 out of 7 transactions, 2/7. Confidence is also 2/2. But here in game support, game is there in 3 documents, that is document 6, document 7, and document 3. But game association associate support is there in only 2 documents. So the confidence is 2/3. So the key operations is to find the rule items that have support above the minimum support, min support, and rule item is of the form conditional set, comma, y, where conditional set belongs to I and y belongs to your class labels. So rule items is of the form conditional sets associates y, where support is rule support count by n and confidence is rule support count by conditional support count. So let us see Apriori algorithm. We'll directly jump to the example. School. So all item supports are given in flower braces and the class labels are without flower braces. The support count of school is 3 and data kavala, or shall I proceed? Do you want data? Shall I proceed?
Yes, ma'am.
Okay, right. So ఒక్కసారి చూసుకుందాం. ఫస్ట్ స్టూడెంట్ అండ్ స్కూల్ కదా. స్టూడెంట్ స్కూల్ 1, స్టూడెంట్ 2. Where is other student? 2 అనుకుంటా. What is that? స్కూల్ ఎడ్యుకేషన్. ఓకే, ఫస్ట్ ఎగ్జాంపుల్ ఒకటి చూద్దాం. స్కూల్ 1, 2 ఎక్కడుంది? 3. స్కూల్ ఎడ్యుకేషన్ 3. ఓకే, రైట్. Similarly, student education, teach education, okay, so on. So whichever is not satisfying the minimum support, we are not including it. So from this frequent items, we are generating the rule school and education with support and confidence, student education. Okay. Now, joining step, school and student have the class level education. Similarly, student and teach. And see, while joining all this, we are we are joining all the things and we are pruning if they are not frequent according to the support count. Okay. So school, student education, from this C2, we got from this candidate generation at level 2, I got frequent items 2. All that which are not satisfying the minimum support is pruned. Is this C2 and F2 clear? So from
Yes,
F2 again, what is this car1 and car2? Yes, class association rule 1, rule 2. So from this frequent items, this is the very simple algorithm. Okay, we are finding the rules. Any doubts? No. No. Multiple minimum class support. Multiple minimum support. See, for one particular topic, some of the classes may appear more frequently, and some classes may appear less frequently. Tell me the example. Class association rule key. One example, which have frequent items, which has rare. Any of you have done online courses in this holidays? కోర్సెరా ఎవరు చేయలేదు? ఎవరు ఇప్పుడు చేస్తున్నారా? మీకు అదేంటి ఐడీస్ ఇచ్చారా జేఎన్టీ వాళ్ళు, లేదా మీరంతకు మీరే చేస్తున్నారా? జేఎన్టీ నుంచి ఇచ్చారా? సరే. కోర్సెరాలో వెబ్ మైనింగ్ అనేసి ట్రై చేయండి, అండ్ డేటా మైనింగ్ అని చెప్పి ట్రై చేయండి. You will get lot of courses based on data mining, but see what you will get when you type web mining. Okay, so web mining, if you take data mining, it is a frequent class, but whereas web mining is very rare, you can take it as rare class. So you cannot specify same support for data mining and web mining. And I want to find all the items that are associated with web mining. Okay, so MS values of web mining should be less when compared to the support value of web mining should be less when compared to data mining. So even in case of class association rules, you require multiple item support. This is one of the example. Okay, and here also by setting the minimum class support to 100%, you are telling the algorithm that except that item, that means you leave that item and generate the rules with other items. Sequential pattern mining. In general pattern mining, or in general frequent item sets, you are not seeing this sequence of items purchased by the customer. The time you are not taking into the consideration. But here in sequential pattern mining, we'll see the sequence of buying patterns of the customer. That means whether he is buying a bread and then a jam next, or else a butter next. What is the sequence of time the items are purchased? And similarly, in web usage mining also it is used to find the navigation patterns of the users. See, these are new terminologies for you. If at all you have not understood, then and there you stop me. I is the item sets, or sorry, I contains the number of items. And sequence is ordered list of item sets, but not items. Remember that. An ordered list of item sets. Then item sets, which is also called as element, is a set of items which is subset or equal to I. And we denote this sequence as S, where each element in S is an item set, which is called as element. I'll show you with the examples again. So one thing, sequence means item set. An element of sequence is denoted by x1, x2. What again? An item set consists of items. Sequence consists of item sets. Simple thing. Item sets consist of items. Sequence consists of item sets. And the elements in the sequence are in order, lexicographical order. Then size and length. Size is nothing but number of elements or number of item sets in the sequence. And length means number of items in the sequence. Have you understood the difference between size and length? Size means number of item sets in the sequence. So if, for example, there are two item sets which contains, next example of the next slide. So I'll explain these definitions with the examples. See, try to say this last line. The size, this is the sequence 3, 4, 5 and 8. So the sequence consists of item sets, not individual items. So the size is number of item sets that are in the sequence, that is 3, and the length is number of items, which are 1, 2, 3, 4. Okay? Have you understood the difference between size and length?
Yes, ma'am.
Next. Coming to the definition of subsequence. Again, don't worry. I'll explain with the example that a sequence S1 consists of some of the elements, is a subsequence of another sequence S2 if every item is subset of the other items in the sequence. This is a good example. We have these items and I have two sequences 3, 4, 5 and 8 and other sequence 6, 3, 7. Okay, so let us assume that 3, 4, 5, 8, 4, 5 and 8 is S1 and this second sequence is S2. S1 is the subsequence of S2 or S2 is superset of S1 if every element of S1 is the subset of the element of S2. For example, if you take 3, 3 is the subset of 3 and 7. Yes, because 3 contains 3 and 7. 4, 5 is the subset of 4, 5, 8. So it is not continuous. That's why we have included another variable j. Okay, if you take any element in this superset, then it should be a subset. 8 is the subset of 3, 8. Okay, so but if you take the item set 3 and 8, 3 is another item, 8 is another item. 3 contains in 3, 8. But 8 contains, there is no other item set. Have you understood? 3 is there in 3, 8. But others 8 should be there in other item set. Is this point clear? Yes. And it should be in what you say? Forwarded way. 3 it should be 3, 8. Okay, then next should be 8 should be in the, according to the rule in another subsequence. All right. Have you clearly understood the difference between size, length, sequence, and subsequence?
Yes, ma'am.
Okay. So our objective is to find the rules. Sorry, given a set of input data sequence, the problem of mining sequential patterns is to find all the sequences that have user specified minimum support. Each such sequence is called frequent sequence and sequential pattern. The support of sequence is the fraction of total data sequences in S that contains these sequences. And let us see this everything with example. So this is the transactional data set, and it is ordered according to the customer ID. So customer ID 1 has purchased the sequence pattern, okay, has purchased item number 30 at July 20, and next item, next sequence at July 25th. Okay, these are the item sets. So let us frame the data sequences. Customer ID, purchased items are 30 and 90, and they should be placed in the sequence only. Next is second 10, 20, so on. Okay. So let their support is greater than 25%. So one sequences are 30, 40, 50 we are not including because 50 is appearing only once and it does not satisfies this support. ఇప్పుడు ఎవరు వచ్చారు? So maintain the timings. Mari half an hour late, 1 hour class lo aithe etla? I need to stop and I'm admitting. Have you understood one sequence? Yes. Next, second sequence, that is joining step, 30, 40, 30, 70, 30, 90, 40, 70. 70, 90 is not there. Why? It is appearing only once. Huh? Yes. 70, 90 is only once. So minimum support is not satisfying. So we are not including 70, 90. Next, third sequence, 30, 40, 70. 30, 40, 70. Why we are, say 30, 40, 70 we are including. 30, 40, 90. Minimum support not satisfying. 40, tell me, can I include 40, 30, 90?
No, ma'am.
Why?
Ma'am, it's only coming once in transaction 4.
40, 30, 90, 40, 30, okay. No, even if you say the sequential pattern, 30, 40, 90 is there, but 40, 30, 90 is not there. Sequence kada. You need to see the sequence. Okay, remember that.
Okay, ma'am.
This is generalized sequential pattern mining algorithm. This is explanation of this algorithm. Joining step and pruning step. So there are two sequences. So two sequences, you have two frequent items. FK1 should be joined with the FK1. So remember this rule. A sequence S1 can be joined with S2 if the sequence obtained by dropping the first item of S1 is same as the subsequence obtained by dropping the last item of S2. Let us see with the example. So these are the items, I need to join it. So this, what is the rule? When you drop the first item in one items and the last item of the other item set, then the resulting should be same. So let us see, I'll drop 1 here. So the result is 2, 4. And I'll drop 5 here, last but 1. So the result is 2, 4. Then I can join 1, 2, 4 and 2, 4, 5. Yes. So my output is 1, 2 and 4, 5. I'm not including 2 because already 2 is there in this item set. Is this point clear? And try to check with 1, 2, 4, 6. What are the item sets to be joined to get 1, 2, 4, 6?
First and last item set now.
What? Excuse me.
First and last item set now.
Okay, right. So you have understood. Then pruning is similar. A candidate sequence is pruned if k-1 subsequence is infrequent. So according to the rule, we got only 1, 2 and 4, 5. Mining with multiple minimum support. So in what case here we require multiple minimum support? So let us see the example. For mining comparative sentences. If you see this sentence, the picture quality of camera X is better than that of camera Y. By seeing this sentence, you can tell that you are comparing camera X with camera Y. Okay, and how you understood that you are comparing X and Y cameras? By seeing the word better, right? So these type, say when you are taking these types of inputs, you can take from or find in reviews or forums or some postings, and you want to mine accordingly, and you want to decide whether to buy camera X or camera Y. But all the users may not use the same words. Here, better is the comparative word. This better is called as comparative indicator, which indicates the quality of X and Y. Okay. Apart from this better, the users may use the words like better, more, less, ahead, means superior. From this set of words, better and more are more frequently used by the users, and ahead and win are rarely appearing words. Okay, so if you see this example, some are frequently appearing and some are rarely appearing. So in this case, using single support is not appropriate, and we go for multiple minimum support. So let the set of items in the pattern PB I1 and I2, so on, and the minimum support of P is minimum of all MS values, the same rule, and the new algorithm is called as MS-GSP, generalized sequential pattern. See, assume that we have a sequence here. Try to understand. I have a sequence 1 to 4. in F3, from which we want to generate candidate sequence for the next level. And suppose that item 1 has lowest MS value in S1. Also assumes that sequence S2 is not in F3 because its minimum support is not satisfied. So as 245 is not frequent, you cannot generate 1245 or 1245. Okay. But however, 245 may be may have, because 245 is having higher frequency. 1245, you understood this? 124 is may not be frequent, 245 may not be frequent, but 1245 may be frequent. Same as previous one. Then how could you generate 1245? So for this purpose, again I'll repeat, I have a sequence 1244 and another sequence 245. I cannot generate or join to get 1245 because 245 may not be frequent or 124 may not be frequent, but 1245 may be frequent. So in that case, what we have to do? So the solution is extending the items. Intama, any doubts? With additional item set. See, 245, 24, 124, remove this one and extend it with 24x. Add another item, or else you can add like this also in the last 4x. Now you can generate the candidates like this. Say 124 is there, 24x is there. When I remove first element, the result is 24, and when I am removing the last element, the result is 24. So now I can join the resultant item set is 1 to 4x or else 1 to 4x. For x, you can add any item. Is this point? So what we are doing to join or to get another item, we are extending the element. We are extending the candidates by using additional item. Is this point clear? Correct. Same repetition. Last line. So as we are extending with another item, different joining strategy we'll use for joining the items. This is the main point to remember. Joining step. The first step. See the first. Can you able to see the pointer which I am pointing? Yes or no?
Yes, ma'am.
Okay, right. So when the another joining strategy is used here, when you are using MS, the subsequence obtained by dropping the second item. Previously, we have dropped the first item, but in this case, when you are using MS values, drop the second item of S1 and the last item of S2. Remember this point. So let us see the example. These are different sequences with their supports. See, So we cannot join 145 with 146. Why? I'm joining the second items, we'll get the resultant 15. And if I drop the last item 6, I get the 14, which is mismatching. So I cannot join A and B. Can I join A and C? Let us drop the second item 4. So I am getting 15. Last item 6, I am getting 15. Okay. So when joining, what you have to do? You drop the second item of the sequence 1 and the last item of sequence 2. Okay. Next. Pruning is same. The sequence is pruned if any item of frequent items at k-1 subsequent is infrequent. That is without minimum support. Okay. So what algorithm we have studied now? Just minimum sequential pattern. And our next topic is minimum sequential pattern based on prefix span. And that I'll explain in tomorrow's class. Thank you. Okay, Nimshan, do not leave. Total number 18. Okay, right. You can leave. Thank you. Any doubts?
No, ma'am.
One chat message? Okay, no, ma'am. Right. Thank you.
Thank you, ma'am.